Number 42. On the day of her birth, Mr. and Mrs. Huang bought $500 in bonds to help pay for the daughter's college education. The bonds paid 6% interest compounded annually. Each year on her birthday, the Hongs bought another $500 in bonds paying the same interest rate. If they continue this tradition, how much will their daughter have in her college fund on her 18th birthday? So, on the day of her birthday, there's $500 deposited. Okay, so you know that given on when she's born, she received $500, and you had an interest rate of 6%, which is, as a multiplier, it's 1.06. Okay. Now the problem is we want to find out what should that exponent be right there. Okay. So let's think backwards for a minute. So on her 18th birthday, she receives $500, and then they figure out the total cost of the account. On her 17th birthday, they give her $500. It has a ratio of 1.06, and it has an exponent of 1. All right, so you're paying, so it'd be $530 for this year and $500 for this year. So this year, she received $500. Again, it's 1.06, but this is over a 2-year period. So now it's 1.06 squared. So if that's, by the way, that'd be 1.06 to the 0, which of course we know is 1, so that'd be 500. That's the first, that's the second. So imagine this is probably going to be to the 18th up here. So if we're looking for the, how many terms do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So it's 19 terms overall. So you're looking for the 19th partial sum. Alright. Now we're going to consider this, even if it's her 18th birthday, we're going to consider this as the first term. This is the 19th term. So this is a geometric. This has a ratio of 1.06. So our value of our first term is going to be 500. 1 minus 1.06 to the 19th power over 1 minus 1.06. So doing all the calculations, let's see here. So if I go 1.06 to the 19th, 06 to the 19th power, subtract that from 1, and times that by 500, I get negative 10,000 or 1,012 and 80 cents. If I subtract 1.06 from 1, I get negative 0.06. Two negatives, a negative divided by negative gives you a positive. So if I divide 1012.80 divided by 0.06, I get $16,879.99. Well, it rounds out to $16,880. So it's approximately $16,880. The actual amount was $16,879, $16,879.99585. So you can see where rounding this would be appropriate. But this is the equation This is the setup right here of how you would work that. Keeping in mind that we're going to make her 18th birthday the first year, 17th birthday is the second year, and if you notice how many birthdays, counting the birth, that there is actually 19 deposits of $500.